Hi, this is Stephen, and in this video we will continue to use the simplified Bernoulli equation, but this time to look at pressures, estimate pressures in the pulmonary arteries. We touched on this before. I wanted to go into a little more detail. So let's start with our peristernal short axis view. We've got the Mercedes-Benz aortic valve right in the middle, and then looping around, you've got your pulmonic valve right here. And then you've got your tricuspid valve, and over here you've got your right atrium and your left atrium. And we are looking in systole in this frame that I've shown here. And in systole, you can drop your continuous wave Doppler right back there, and you may get a tracing that shows the velocity leaking backwards during systole through the tricuspid valve. We can take this Vmax, the regurgitant velocity, and we can use that to estimate the RVSP. And again, this is sometime in systole. I'll just draw it, somewhere right about there, let's say. And the formula, if you recall, we have our high pressure, which is our right ventricular systolic pressure. That's our pressure in the right ventricle, minus our right atrial pressure that we'll get just looking at the neck, jugular venous distension, is equal to 4 times our velocity of the tricuspid regurgitation squared. And so thus our right ventricular systolic pressure equals right atrial pressure plus 4 times our velocity of tricuspid regurgitation squared. Now, if there is not a stiff pulmonic valve, then you can actually, this is probably equal to our pulmonic artery systolic pressure. If the valve is stiff, then this is not true. Now we can actually look at a different time as well. So over here, again, our aortic valve, and looping around here, we've got our pulmonic valve. This time I'll draw it closed, and we'll draw the tricuspid valve open. So this is during diastole. And during diastole, I can instead take my continuous wave Doppler right there over the pulmonic valve, and there may be a little bit of blood flow that's leaking back, a little bit of pulmonic regurg. Before there was some tricuspid regurg, but now there's pulmonic regurg. And so how do we use that? Well, we're in diastole here, right? So we're P, QRS, T, P, and then right before the QRS, we're at end diastole in this frame. What kind of a graph would we get? Well, we'll get something that looks like this, where there's that blood that is leaking back across the pulmonic valve. And if we measure the velocity right at that point there, right at the end of diastole, that gives us, and we take that value, so this will be the velocity of the pulmonic regurg. How do we use that? Well, we can say that the pulmonary artery diastolic pressure, that's our high pressure, that's the pressure down here, pulmonary artery diastolic pressure. And let me do that let's do that in a coordinated color here. All right, so our pulmonary artery diastolic pressure, or the pressure out here, minus, what's our lower pressure? Well, this is interesting. You might say, oh, the lower pressure it's right across the valve, it's the right ventricular pressure. Yes, it is the right ventricular diastolic pressure, but notice that the tricuspid valve is open, and so the pressure in the right atrium and in the right ventricle is about the same. So we can actually say the pulmonary artery diastolic pressure minus the right atrial pressure, that is equal to 4 times our velocity of the PR jet squared. Hope this color is not too light for you to that you can still see it. I'll do a little bit of a brighter purple here. So we can say that our pulmonary artery diastolic pressure is equal to the right atrial pressure plus 4 times our velocity squared. So we have a formula now for pulmonary artery systolic pressure. We have a formula for pulmonary artery diastolic pressure. And so you can actually use that to figure out your mean pulmonary artery pressure. There's a couple different ways, but you may recall a formula that says if you take your diastolic blood pressure plus 1/3 of the difference between your systolic minus your diastolic blood pressure, that equals your mean blood pressure. That's one way to do it. You can also, there's an approximation where you can, so that's one way. Another way is you can just take 0.6 times your pulmonary artery systolic pressure. And that, sometimes people will add 2 there, that is another way to approximate your mean pulmonary artery pressure. Or a third way that you can do it, just as I mentioned, that the computer can actually do mean gradients. And so if you take the area under that curve and the computer gives you a mean gradient, if you were to take your right atrial pressure plus the mean pressure gradient that the computer calculates from looking at all the different velocities in that regurgitant TR jet, the mean gradient, and that's another way to get your mean blood pressure. And if your mean pulmonary artery pressure is above 20, then that would correspond to pulmonary hypertension. So again, just looking at the top, if we're looking in systole, we can use our TR jet to estimate our right ventricular systolic pressure or our pulmonary artery systolic pressure, if the pulmonic valve's okay. And during diastole, we can use our PR jet to estimate our pulmonary artery diastolic pressure. And then you can take that diastolic pulmonary artery pressure and the systolic pulmonary artery pressure and figure out the mean. So just another application of the Bernoulli principle.